My name is Vikas Goyal. How We are talking about change detection today. First of all, I wanted to congratulate Google team for releasing Angular 2. I'm excited about Angular 2. I'm hoping everyone else is. So is excited about Angular 2. Yes. Great, great, great. Okay. So as I said, this talk is about change detection, and we'll be mostly focusing on Angular 1 and Angular 2. A little bit of introduction. My name is Vikas Goyal. I'm a manager at Sapient interactive development domain. I'm a full stack developer, a technologist. I've been using Angular for over 3 years now. And as I said, I'm excited about Angular 2. So in today's talk, we'll be basically covering what is change detection, why do we need it, how different MVC frameworks achieve change detection, and if time permits, when it is done in a MVC framework. Okay, so the first topic is what is change detection? So change detection we're talking about here is in with respect to MVC frameworks. And by definition, a change detection is a process to detect changes in model to update the view. Now, when you're first loading your application, your MVC framework, it has a task of taking your view template and your model and basically bind them together to produce your HTML markup. And it just simply renders it on your page. But once your application has started running, it becomes extremely difficult for your framework to detect what has changed in your model. So in any MVC framework, updating view is an important thing. And that's what change detection does for you. It tries to make sure your views and your models are in sync. Okay. Let's look at some of these frameworks, how they do change detection before we jump onto Angular 1 and Angular 2. So how is this done, right? You want to take a look at that again? Okay, so let's start with Backbone. Apologize, I have to do 2 slides. So first of all, the most important thing about Backbone was the first most popular MVC framework, if I'm right, was introduced. And it was very simple. And the most important thing about Backbone is that you don't have your regular plain old JavaScript object as your model. You use Backbone's model extend to basically inherit from that model. And same cases for the views. So you have your view extended from your Backbone view. Now, if you look at this, you will see that the way it's happening is that we are attaching event listeners to your model. And then we are calling this dot model dot set to set a specific property. It's important to see here because you're not able to say model dot completed equal to true. You cannot say that in Backbone, simply because the Backbone request requires you to use the set method. When you do that, that basically calls your function that you provide on your listeners. So when you do this dot listen to, you attach your model to when you do this dot model and you provide an event, your model is going to be able to notify application that something has changed. Then you have to provide a render method, which is going to be called, and the rendering will take place. So all these pieces come together, and then you're able to see changes. So this is how change detection basically works in Backbone. So important points to take away from this is that you're providing your own render method. You're not able to use plain old JavaScript object. Let's see how Angular1 does it. So in contrast to Backbone, where you cannot do a POJO for plain old JavaScript object, you're able to do that exactly that in Angular. So you have in this case you have your to-do model, and you're simply able to change the title here. What you're looking at scope is basically just a context for your controller, and Angular maintains those scopes, and it basically runs something called digest loop, run through those scopes from top to bottom to see what has changed. Also important to notice here is that when Angular is loading your template which is here in the view, what's happening is it's actually converting or translating your bindings into watchers. So what you see on the right side is watchers. So every single binding in your model is going to be translated into a watcher. For example, here you have to-do.title. It's getting translated into the first watcher, which has all these properties. In the same case for your ng model. Also important to note is that you have your last property in your watcher, and you have a function in the watcher. You can see other properties also, but the most important one are these two. Last property saves your last value, and after that, you can imagine, once any change happens and digest loop is running, it's going to compare your watch property, last property value with the new value, and it's going to run your fn function that you provided here. So that's how Angular1 does change detection. Also, if you look at the last part of these the left section, you'll see that you are able to create your own watchers. That fact is very important, and we'll come back to that and see how that affects change detection in Angular1. Now let's jump to React. React goes one step further. It doesn't do regular dirty checking. It offloads the task of letting the framework know whether a specific property has changed or not to you. So in case of React, what you do is you simply call this function called this.setState, and you provide what has changed. And framework is going to schedule it for re-rendering of the DOM. Also, as you might hear that React is going to re-render your whole DOM on any single change. That's true, and that might look like a bad decision for performance. But in fact, what React does is it basically does a diff of, so it keeps a copy of your DOM in a JavaScript object called virtual DOM, and it does a comparison between your new virtual DOM with your old virtual DOM, and basically renders or updates only the parts that needs to update. So that's React. This is supposed to be hidden, but I guess. Okay, so let's jump on to Angular2 now. Angular2 has reinvented change detection. So first thing I want to see is why did Angular2 did that, right? So let's quickly take a look at Angular1's digest loop. All right. As I was saying, in your Angular1 application, you have a bunch of scopes, which are basically a context for your controller. And they hold a bunch of watchers. As you see, W stands for watcher here. And when you're running this digest loop, and if you are, let's say, in your watcher, one of your watchers, if you're updating one of the model properties. So let's say this watcher here, the last watcher here, updates your title. Once it does that, it's going to be a change in the model, and Angular will realize that the model is not stable anymore, and it's going to basically do a rerun of your digest loop. So it's clear that when you are running a digest loop in Angular1, there's no guarantee the digest loop will run only once. In fact, it's pretty easy to actually run this digest loop into an endless loop by just updating your model in your watchers. So that's why I mentioned that it's an important fact that you are able to create your own watchers, because then you can do whatever you want. You can run expensive code there. You can update a model property, make it unstable, and that will trigger another digest loop. All right. All right. Let's see how Angular2 is going to solve that. So first of all, the way Angular2 works is it thinks in terms of components, just like React. So you're thinking always in terms of components. You are not thinking about controller, and you're not thinking about scopes. You're thinking about application as a tree of components. So you have a bunch of components, and the most important part for change detection is that your change detectors, each component has its own change detectors. Okay. What that allows us to do is it allows us to basically control change detection at component level. So just like in Angular1, what you were doing is you were running a digest loop, which is going through every single one of these scopes and checking every single scope's properties to see if they have changed or not. Angular2 allows you to control whether the property is supposed to be checked or not through its own change detector. So every component can say, I want a specific property to be changed or not. Okay. Also, uh, change detection in Angular2 runs only one cycle or one pass. We just observed that in Angular1, you're able to run change detection uh, multiple times. You can even run an endless loop, basically, which will be short-circuited by Angular1 code to 10 iterations. But you can still do it, right? But in Angular2, you're not able to do it. You're not able to. Angular makes it really hard for you, first of all, to basically change your model while your change detection process is running. So if you look at this code snippet here, and also I have to mention that this is it's actually running two passes in dev mode. We'll talk about that. But if you see the snippet of code, you'll see that what Angular is simply doing is it's asking every single one of these change detectors on components to run their change detectors, and then each component is going to run its own its children's change detector, and so on and so forth. So it's a simple directed graph traversal of the tree. If you see in the dev mode, it's going to check if there are no changes made during the change detection, and if there are any changes made during change detection, it's going to throw an error. And again, that's only in dev mode. In production mode, it'll be silently ignored, so you better not do it. Actually, it's going to be very difficult for you to do it. I couldn't really reproduce that error once I had done it before. Okay. Let's take a look at how it's happening, how this whole thing is happening in Angular internally. What Angular is doing it at compile time. So remember, when you were doing Angular1, you were doing a compile time and you're creating watchers. Angular2 is something slightly different here. What Angular does is it takes your change detectors, it takes your HTML and your TypeScript code from your component, and it's going to create a class out of that. The class is called the name of the component .ngfactory.js. This class has create internal, detect changes internal, and all the event handlers associated with each component. Detect changes is something that of our focus here today. So we'll look at that quickly. I'll show you. I'll let you take a quick look at how this class looks like. But the class is making Angular's components very self-sufficient and autonomous. What that means is they're able to create themselves, they're able to detect changes on themselves, and they're able to re-render themselves. Also, they're able to handle all the events on them, right? So that power that is given to Angular2 components makes them really the key thing for this Angular2 application. Also, as you can imagine, in detect changes method, there'll be a simple triple equal check for all your bindings, all the things that are used in your templates, and compare. If they are not equal, then just re-render that part of the component. Also, AOT and GOT, which means ahead of time or just in time. These templates can be compiled ahead of time so that you can save load time when Angular first compiles your template. Okay, let's take a look at some code. So anybody so far has any questions on what we just, yeah?
Looks like you have worked with like React, Angular, and other platforms. Like, what do you think the most like benefits between them?
Between Angular, React, and
Backbone.
Backbone. See, every single, so I never see all platforms like one size fit all. I think there are different applications have different uses for these MVC frameworks. For example, if you are rendering performance is important to you, and if you are rendering like thousands of components, you can get very good help with the Angular2's change detection, which we are going to see shortly. I cannot talk much about React, this being Angular conference, but I don't know if I'll be kicked out for the next conference or not. So yes, if you were to render a lot of components, I would recommend using Angular2 over Angular1. Hope I answered your question. Thank you very much. Thank you very much. Yeah. Yes, I'm gonna be the second man to Donald. Yes.
I think you may have just answered it, but why would they make it more difficult to re-render a model or something? Like you were saying with this change detector, you can only have one single pass. What does that actually mean?
Okay, good question. Actually, what that means is when in Angular 1 you're making a change to one of your model values, it has to run through every single scope and see what has changed. Because there's no way to know. So JavaScript doesn't provide you a simple way to know if something has changed, right? So, you run through that cycle, and then if something changes during that cycle, you evaluate that process again. You run the process again and evaluate all those bindings again. So actually, you're doing the same thing over and over again, right? Whereas in Angular 2, what you're doing is you are basically running that process only once, and you have no way to basically make changes in that cycle. If there are changes to be made later on, you can make those changes and run the process again, but you will never be in a loop. So basically, you're trying to short circuit the loop right from the word go.
So it's just a locking mechanism?
It's basically a mechanism to allow you to make changes or batch changes together, rather than make changes and then run this thing again, and make changes and run this thing again continuously, right? Hope that answered your question. Okay, thank you.
Clearly, you're not a fan of it, though.
It does run through your watches only. So you know what? Since that's going on, let me proceed with the one of the slides that I had. Uh, with Angular 1, when you're running through these properties, you're basically simply comparing those values with each other, right? And with Angular 2, you should be able to not only compare those values on the change detector, you should be able to skip certain part of the tree. So, for example, let's say you have, like you saw the component tree, and your application is made of, let's say, 1,000 components, and certain part of the tree is re-rendering frequently, right? Let's say it's re-rendering 100 times in a second. Now that's gonna stop your application from performing. It's gonna drag basically your application. So in order to fix that problem, you're able to say, I want this part of the tree to be skipped from change detection. All right, and that's a key thing. That's very important. Okay, so this is an Angular 2 application, and this is a to-do application, to-dos, and I'm gonna try to make it quick. Uh, you have a to-do list, which has, as you saw, an input box and a bunch of to-dos that you can add. You have a footer which says mark all completed. Important thing to notice here is that your to-do, what we are doing is we are creating, sassy. We have a bunch of to-dos created through ng4, which is equivalent to ng repeat in Angular 1. Am I speaking close enough? And also, if you look at this part here, what we're trying to do, what we're doing is we are actually passing to-do as an input property to this new component. All right, and to-do.html is pretty simple. It has a bunch of properties used here. Also, I want to quickly show you how to-do models look like. So this is a plain old JS model, and it has certain properties like completed, editing, and author. Whatever I'm creating through this application, it's going to be created with my name on it. All right, because it's my presentation. All right, so let's go back to the. So what I was trying to say is that you are creating to-do HTML. You're using to-do HTML and to-do.ts, and that's going to translate your Angular is going to translate your code into factory, and Chrome. I can never get used to it. What is that?
Command tab.
Oh, command tab. Okay. Command tab. Okay. Thank you. All right. So what we're seeing here is basically a quick code snippet of what. Can you see? Can you guys see? All right. So as I said, this is generated through code. I didn't write it, so don't crucify me for this. It's done by the Angular's compiler, and the two methods that are most important for you to see. Actually, the first important method is create internal, which basically is handles creating this to do for the first time, and then more important for us for this discussion is detect changes internal. So if you see it closely, you'll see that it has a editing and then it checks if editing. Don't worry about all this check binding and all that. It's actually simple, a triple equal comparison, and all it does is if the change happened, then it's going to do something. If doesn't, then do something. For example, the last one, which is here, is a todo.title. If the change has happened, then it's going to render the text on that specific component. So this is something that is generated at compile time by Angular, right? This is what I wanted to show you. And then we have to switch to the slides now. But okay, you know what? I'll do without it. All right. So there was a nice animation there, though, but that's fine. Okay, so let's try to do something. Let's see. Let's quickly put a breakpoint here and see if I change something here, which is let's see. If I say mark all my to-dos complete, did I click? Maybe I think it did. So if I mark all my to-dos complete, it's going to run this how many times? Okay, it ran twice already. So any guesses how many times this code will be called, which is running change detection on this to-do component? Any guesses? Four. Four is the right answer because we are in dev mode and there are two to-dos, so it's going to be running 4 times, right? Okay. All right. Okay, it's 4 times. All right. So let's remove this breakpoint, and let me quickly command tab console, and okay. I'm gonna switch to a different branch which allows me to import to-dos, and let's see what happens there. Okay. All right. That would have changed our application, and I have to do this. Okay. So if you see, now we have ability to import to-dos. All right. So what I'm going to do, I'm going to click import, and I have 1,000 to-dos here. All right. They're not really to-dos. I'm just cheating here, but you get the idea. And what I want to show you is that if I were to put a breakpoint here now, so as I told you, there are 1,000 of them, and we have this ng factory. Let's go there, and let's quickly put a breakpoint here. I'm not going to really run through this breakpoint, but I'm just going to ask you this question again, so be ready. So detect changes internal, 1,000 to-dos. When I say mark all my to-dos complete, I forgot to mention that all to-dos except my to-dos are not my to-dos. So right, so the first 2 are mine. Everything else is someone else's to-dos. Right. So now, with that in mind, what will happen is when I click mark all my to-dos complete, it's going to check only first 2. Like it's going to mark them complete, but it's going to leave rest of 1,000 alone. Right. So with that, any guesses on how many times we're going to hit this breakpoint now? Okay. It's okay. You can say a higher number. It's fine. It's fine. Okay. Well, great. It is 2004. Good job. Okay, so the reason for that is by default, Angular is going to check every single one of them, right, twice. That makes it 2004, right? Just so that you don't think I'm lying, I'm going to do it like 5 times, right? Oops. If I can click on this thing. Can you click it for me? Oh,
Really? You don't have a laser clicker?
it's
Tough.
This is so just imagine I clicked on it. All right. So just trust me on that. All right. So you want to click that?
How do you click? I mean, I'm clicking.
Just
60 something. What?
no, you don't have to set a breakpoint. Just okay. So right. Right. So all right. So let's go to the next part here. So what I showed you that if you were to create those 1,000 to-dos, and if you want to just modify only 2 of them, actually 1,002, and you modify 2 of them, then it's going to run your change detection 2004 times, right? That's bad, right? That's bad, right? So how do you fix that? What you can do with the Angular2 is, as I said, you can control change detection. You have the power to control change detection. All right. So let's use the power. Okay. So for that, what I'm going to do is I'm going to, oh gosh, I wish I had slides. Okay. So in Angular 2, what it does is it introduces something called a change detection strategy. In any component where you want to say, I don't want to run change detection on this component, you can say change detection strategy dot on push. So let's check out some code which does that. Okay. And how does it refresh this thing? Okay. All right. So if you see todos.ts now, you should see that I have a change detection strategy and I'm putting on push here. Okay. Also, I wanted to show you quickly the code that marks that to-dos complete. So you have this .todos for each simply running through the to-dos and then marking those to-dos with my name on them to complete, right? Um, so great. So we just put on strategy on push. What happens as a result of that? Ooh, breakpoint finally. So all right. Let's go out of this. Let's import certain 1,000 to-dos. All right, and then mark my to-dos complete. And it doesn't work. So what happened is we just told Angular, do not worry about checking my to-dos. And Angular said, okay, all right, whatever you say. And it stopped monitoring any changes to my to-dos. All right. So now we have a problem. We have to make sure that it does that, right? We have to re-render only two. So ultimate goal of this thing is that we are able to run change detection only 2 times for 1,002 components. All right. So in order to do that, you simply have to make sure that you mutate your component. All right. So as I showed you in the beginning, that you are passing this to do as an input property to the component. If you were to simply change the reference of this, Angular will recognize this because the definition of on push is that I'm going to check only properties that you're passing from outside. All right. So in order to do that, let's go back. And let's quickly check out this. Let's see the code quickly, see what changes I've made. So instead of simply updating the property of that object, what I've done is I've created a new object, a new to-do for any to-do which has the same author as my name. By doing that, I created a new reference. And by doing that, let's see, and I import, I have 1,000 to-dos. And you know what? Since we can, let's try to set up a breakpoint. All right, so if I click on that, as I said, Angular is going to remove change detection because I had on push. But Angular said, if you are going to change the object itself, I'm going to just change that specific object, not everything else, right? So if I do that, you'll see that's going to hit. Okay, how many times this time? Okay. You know so much Angular 2. You should speak. Okay. The only reason it does twice instead of well, if you said 4, you're still good because only reason it doesn't do a second check because it's not going inside the property. It's actually looking it from the outside, and it doesn't have to do the second time. But yeah, see, it ran through those. Well, it didn't run through all those to-dos that it didn't have to, right? So that's it. The last part of this presentation is something cool you can do with Angular 2. You want to see something cool? All right. So change detection not only allows you to simply modify a specific property saying on push, and then you control it that way, you can do much more. So imagine a scenario, you love cats. Let's say you love cats. Who doesn't, right? So you love cats, and then there's a server which is sending you cat photos, all right? Bunch of cat photos every 10 milliseconds, right? And you're like, wow, I love cats. I want to see more and more cat photos. Interesting, right? We're warming up to that, right? So now what happens is your user is fine because yeah, they're able to see so many cats, but you as a developer are struggling simply because your application cannot handle that many cats, right? Right. Well, so what we do is we convert this app quickly into a cat application. Let's make it a cat's to do. All right. So I'm going to get rid of this breakpoint, and we're done with breakpoints. So let's get the way done. All right. So let me quickly do another switch. Okay. And I need another as a it's not installed. Oh, okay, I do npm install. Sorry. I cannot type with one hand. Sorry, some sense? Yeah. Okay. Okay. No errors. All right. So let's go back and do what we wanted to do. Let's go to the app. Oh, I'm not speaking in the mic. Okay, so we got a cat. The application's still called to-dos, but yeah, we have cats there. All right, so what we're going to do is we're going to have thousands of them. They're all the same. That's fine. We'll get more cats. And then what we do is we do stream, and I guess something happened again. Something is missing. Okay, so what's happening here is we are getting cats, but for some reason it's not loading as fast as it should, right? And my application is lagging. It's like, right? I cannot scroll, right? And now we have different cats also, by the way. So uh, that's your problem. Now, how do you fix that in Angular 2? In Angular 2, what you want to do is, as a developer, you want to say, hey, listen, you're sending me these cats every 10 millisecond. That's too much for me. I cannot handle this much load. So what basically I want to do is I want you to see all the cats, but not that frequently. Let's do them every 1,000 milliseconds, which is 1 second, and that may help, right? So in order to do that, Angular makes it super easy to control that part of your change detection also. So let's quickly take a look at what is happening here. So I'm going to just uncomment some code, and you'll get less cats. I don't know if that is exciting or not. Okay. All right. So what I'm doing here, I'm saying change detection, detach. I don't want you to detect changes for now. Just wait. But after 1,000 milliseconds, detect changes. So even though my server file, if you see my server file, it's sending them. Okay. Sending them every 10 milliseconds. I'm saying don't give it to me. Don't give it to me more than once in a second. And okay. Oh, I did that again. I have to kill it because there are too many cats. Right? Yeah, cats all over the place. Okay. So yeah. So let's do this thing again. See if this change helped. Let's start streaming. Oh, you know what? I forgot something. My server must have died by now. So stream is not working. Yeah. Okay. So let's see. Let's refresh it. Make sure the server is running. Server's running. Yeah. Okay. And import stream. Okay. So as you can see now, the cats are coming much less frequently. I can. Right? Don't you love that? Okay. So yes, so what that demonstrated to you is that you have a lot of control over your change detection in Angular 2. Okay, and basically you can change your strategy. You can remove a component from change detection. You can control change detection if you're getting a lot of information together. All right, that's it. Thank you so much.